All right, morning, afternoon, whatever this is. Give me a second to get organized here. So I went through and worked out all the problems in advance. I wrote out my work and then figured it'd be easier to just talk through it while I'm going, just like the gateway videos I did. So hope you guys are all doing well. I miss you, and here's some calculus. All right, so in this first problem, this is the main idea as to what's happening, and they really like these, and it wouldn't surprise me if there were one of these on your test. I mean, I'm completely guessing, but it gets a lot of concepts at once. So what they're telling you is there's 20 people in line at the beginning of the situation. The rate at which people enter the line is this R of t, this equation they give you here, this mess here. And that's in people per second, so that's kind of like your derivative level, because it's a rate. People is an amount, so it's like the original level. And then this is the rate at which people exit, so this is also a rate or a derivative for people per second. And then in part A, they're going to ask you in different versions of this, how many people came in during this time, how many people left during this time, when were there the most people, when were there the fewest people, things like that. So the first one here, and I don't know what's going on with the pixelated screen, but I fought with it yesterday for a little while and I couldn't really get it to work. I'm doing it at home, so it's just a different setup. I don't know, hopefully it's not too bothersome. So anyway, for part A, they ask how many people enter the line. Well, this is the entering, and we're at people per second. So to go from people per second to people, go from a rate to an amount, we integrate. And I would integrate this one on the calculator. This is a calculator available question, so let's use that. So what I typed in, I got this from before, is the integral, just to remind you how to do it. So that's the answer, but just let me scroll through how I typed it here too. So if you hit F3 for calc, then you can hit integrate. And then I'm typing in the equation, so 44 times, x divided by 100 to the third times 1 minus x divided by 300 to the seventh. And then you put comma x because you're telling the calculator what variable you're in. And then comma 0, comma 300 because that's the limits that you're integrating. Davis Unfiltered here. So that's 270, and that's your answer. There are 270 people that got into the line in the first 300 seconds. Part B says during the time between 0 and 300 seconds, there are always people in line. How many people are in line at the 300 second mark? Well, there were 20 to start with, plus the amount entered, minus the amount exited. So there were 20 at the beginning, 270 came in, and they were leaving at a rate of 0.7 per second, so 0.7 times 300, and if you just calculate all that out, you get 80. Part C, what's the first time t that there are no people in line? Well, you had 80 people in line at the 300 second mark. That's what we just found in part B. They're leaving, and there's no more coming in because they stop after 300 seconds. And they're leaving at a rate of 0.7. So if I just divide that out, I get 114.286. And I almost got stumped there, and I almost put that as my answer. But that's 114.28 seconds after the 300 second mark. So your actual answer is not until 414.286. And then part D is, this is rough. It's going to be tough to go through on here. But I would also say it's important to understand because, again, this, in my opinion, is a fairly likely setup to see on the test because it's got derivatives and integrals kind of at the same deal. Okay, so they want to know when is the people in line a minimum. So you are finding an absolute minimum here. So when you find an absolute minimum or an absolute maximum, your job is to check the y value of critical points and endpoints. We've talked about this. I put some graphs on the board and you guys drew out some lines, kind of looked something like this, and the peaks and valleys always happen either at endpoints or at critical points. So the endpoints are 0 and 300. And then this represents the amount of people that there were at that spot. So at the start, there were 20 people. And at 300 seconds, we found this before, there were 270 people. So that's checking my endpoints. Critical points, well, critical points is like when your derivative equals 0, or think about it as your velocity equals 0. If your velocity equals 0, then your rate in is equal to your rate out. My rate in is r of t, my rate out is 0.7. And so I'm going to solve that in the calculator. So I'm going to go F2 solve, and I'm going to type in that equation. So 44 times x divided by 100 to the third times 1 minus x divided by 300 to the 7th equals 0.7x comma x, because you got to tell the calculator what variable that you wanted to solve for. So this one takes a second. I think it takes a minute or two, if I remember from doing this yesterday. So I'll kind of let that sit. The answers you are going to get, hopefully, are 33 and 166.575. Well, those just become 2 more points that you have to check. So really, I could have put them over here. And then I'm checking the y value for each one of those. These are not endpoints, but I'm just trying to organize it slightly less worse than I did before. Less bad than I did before. Sorry, my calculator didn't give me what I expected, but I just put an X in wrong. Anyway, these are the 2 answers you should get. And then your job is to find out how many people were in line at those 2 spots. So to find out how many people were in line at 0, we know at the start of the problem there were 20. To find out how many people were in line at 300 seconds, well, we did that in part B. To find out how many people are in line at 33 seconds, you got to integrate the rate at which they're entering, add 20, because that's how many there were to start with, and then subtract how many have left at 0.7 per second in 33 seconds, and you get 3.8. Same thing with this 166.575. So we're going to integrate it to find out the amount of people that entered. We're going to add the 20 there that were there to start with, and then we're going to subtract 0.7 times 166.575. And with question asking is at what time is the number of people in line a minimum? And this is your answer, because 3.8 is the fewest people that there were in line in this whole scenario. Here, my calculator finally solved that problem if you want to see what I got there for those 2 x values. All right, so spend some time on that, work with it if it doesn't make sense. Battle through it, look at the links I sent you, email me. I got my office hours, whatever I can do to help, please let me know. All right, number 2 here. Again, this is a calculator question, so let's take advantage of that. So they're giving me velocity here. So that is, meters per second or feet per second or whatever. It's a rate. And then they're asking me, okay, part A, what's the acceleration? Well, think, how do you get from velocity to acceleration? We take the derivative. So what I'm going to do in this, I'm going to show you how to do this stuff on the graph. Just to give you like a different option here. So I got those absolute value signs there for a reason. We will get to them in a second, but let me get rid of them to show you this part. So if I graph this, and of course they can't give you like a friendly equation that graphs in 2 seconds. It has to be this crazy looking fellow. I'm going to change the window a little bit because we don't need to see all that. My x values, let's go from so they're only asking me between 0 and 3.5. So I'm going to make my x min 0, my x max 3.5. The y-min, I'm not quite sure how high it goes. I'm just going to leave it. Let's see what we get. So it goes a little higher than I made it, but that's okay. Yeah, actually, let's zoom out a little bit. So let's make this, say, -2 and 3. See if that gets it. Try to graph it again. -2, not 0.2. Okay, so they're asking me for the acceleration. Well, that means take the derivative. So if you hit F5, you get these calculus options here, and I want to know the derivative. So I'm going to hit derivatives, and then these are kind of grayed out, so you're kind of stuck choosing dy dx. And it says dy dx at what? So they want you to type in the x value. So if I type in 3, it gives me the derivative at that spot, which in this case represents the acceleration, and you can just write that. There's no work to show on the calculator. Actually, I'd probably write like v prime of 3 equals -2.118, something like that. But that's not a huge concern. All right, second part. Find the position at time equals 3. Well, we have velocity. We got to go up a level to position. So how do we go up a level? Is we integrate. So I'm going to integrate. So I'm going to go back here and hit F5, integrate. And I want to integrate between 0 and 3. So I'm typing in 0 and 3 for lower and upper limit. And it's going to shade all this for me and give me the integral. We're going to have to add 5 because at the start of this experiment, the particle was at, I'm sorry, we're going to have to add -5 because we started off at -5. So we do -5 plus this, which is why I just get in the calculator. So -5 plus 3.23979. And that's my answer. That's position. Now remember what this means. So if I go 3 to 5, this only integrated 0 to 3, that shaded part. So 3.5, it would actually go over here too. And they're saying in part C, tell me what v of t is if I integrate it, and then tell me what the absolute value of v of t is. So if you imagine, let's imagine this were filled in. And then imagine this top area was like 8. Wish I could write on here somehow. Let's say that top area is 8, and this bottom here area, the little piece over there, is 2. Well, if I integrate the actual function, the answer is going to be 6, because it's going to make the top positive and the part below the axis negative, and that answer is going to be 6. And that's the displacement. That is how far am I from where I started. So taking all the positive, negative, forward, backwards into account, I went 8 forwards and 2 backwards, and my answer would be 6, and that'd be the displacement. Well, if I wanted to graph the absolute value of it, what it would do would be flip this part up here. And now if I integrate it, I get 10, and what that represents is the total distance that you've traveled. So in this example with the easy made up numbers, I went forward 8 and backwards 2. So I ended up 6 units away, that's the displacement. But I actually traveled 10 units, whatever this is, because I went 8 forward and then 2 backwards. So that's what they're asking for here. If you just integrate v of t and you just type it in, 0, 3.5, it's going to give you 2.844, and that's the displacement. When I integrate the absolute value, so that's what you saw at the beginning when I was back here typing this in. You can go all the way to the beginning, go catalog, and you might have to scroll through. Mine's right on it because I just used it, but you want absolute value, and then it opens a parentheses, so you go all the way to the other end of this mess, close the parenthesis, and then you can see your absolute value signs there. And now if you go to graph it, you'll see what I was talking about. So that absolute value makes all the y values positive, which will make the y value right here bounce back up off the axis. And if I integrate now, oops, 0 to 3.5, it's going to take a second because it's got to fill all that in. But basically it's taking this little part over here and it was negative before, so it's coming off of the total, but now it's going to be added to the total. So it's going to make everything positive and add up all those numbers. The answer is, it's right here, this 3.737. And we're not going to wait for it to shade, but you should be able to type that in and get your answer. It just takes the calculator a second. Part D, second particle with the position given by this equation here. At what time are the two particles moving with the same velocity? Well, if I want the velocities to be equal, I need to set the velocities equal to each other. So that's the velocity. The velocity here would be 2t minus 1. And then my job is to set those two things equal, which again, you have your calculator, so I'm going to use that. So here my shaded part is actually finally finished. Yeah, okay. So I can now go back to my regular old home screen, and I'm going to use Solver. So I'm actually going to go back up to this one because I already had it in. I don't want to type all that again if I don't have to, and I don't have to, so I'm just going to leave it. And remember, at the front of that was the solve. So I think it's F2 solve, and then I just open a parenthesis and start typing that giant equation. And I want it to equal 2x minus 1 because that's the velocity of my second equation. And then I'm telling the calculator comma x because I want the calculator to understand what it's supposed to solve for. And again, I think this one takes a second, but here's your answer. So I don't know that we need to wait for it, but there we go. All right, number 3. So we had just started talking about these a little bit before we left. This is one of those where they're giving you, so they give me a graph of G. So this graph here is G, but they tell me that G is the derivative of F. So that means G is equal to F prime. So they told me this. And F is actually a level above it. And then if they ask me about either of these, it's a level below. So F is actually the integral of what you are seeing here. And it's important for part A. Important for all the parts, but for part A, and these were in your gateway. There were a couple of them, or one on each one. We had to kind of find this missing piece. So they're telling me to find f of 1, or to find f of -5, and I know f of 1. So that means I'm going to use those two x values, and I'm going to integrate g of x, and I know that gets me to f of x. And then I know that integral. Well, how'd you get -9.5? Well, I'm just counting. Between -5 and 1 is this area here. So right there is -9. I'm just literally counting those boxes. This is -1.5, and this is 1. So if I add all those up, I know that integral is -9.5. And then I know algebraically, when I integrate g of x, I get f of x. And the way we solve that is plug in the top number minus plug in the bottom number. Well, they gave me the f of 1 is 3. And then you can work out, it's just algebra from there. The hard part is certainly setting it up. Part B, they ask for the integral between 1 and 6. Well, that's a little tricky because you got two equations going on there, or two things. One's not even really an equation. From 1 to 3, to integrate that, again, I'm just counting the boxes. That's 4. And then from 3 to 6, I need to integrate the equation that they gave me. So 2x minus 4 squared times dx. So that's what I did here. So just working through my work on there. I don't need to use u substitution because if I made u equal to x minus 4, du is just 1. So I don't have to make any adjustments. So I can just kind of roll with it like it is. So I'm going to add 1 to the power, multiply by the reciprocal of the power. When I got my 6 and 3, plug in top minus plug in bottom. You should get 6 plus the 4 they originally gave you is 10. All right, part B, or part C, tell me where f is increasing and concave up. So if f is going to be, f is the original function, remember, this original guy. If f is going to be increasing, that means this level has to be positive. So f increasing means g is positive, and f concave up means this is positive. because that's the second derivative. Well, g prime is the slope of this. So g has to be positive and have a positive slope. And the only two places those happen are there and there. So 0 to 1 and 4 to 6. We are both above the x-axis and increasing. So here's my me writing that out, what I just said. And then part D, point of inflection. Well, point of inflection happens when the second derivative switches from positive to negative or negative to positive. Well, the second derivative of f is the first derivative of g, and so that's the slope of this graph, and I want the slope of this graph to switch from negative to positive or positive to negative. And right here is the only spot that happens because we get a relative min there. These aren't really points where things turn around because it's like flat, turn, flat, turn, flat, turn. But right here, there's that corner. Again, hopefully remember that. This is definitely not easy to miss instruction on or mispractice on and then jump right back into it. Number 4. Let me find my stuff here. Okay. All right. Height of a tree. Twice differentiable just means you can take the derivative twice. So it's continuous, it's differentiable, it just means like it's an okay function to use all of our rules are okay here. Use the table to estimate h prime of 6. So this is your h. H prime is the derivative, which is essentially the slope. Or think about it like, you know, h is in meters, h prime is a rate of change. So we want to get the change in meters, which is meters divided by time or by years. So meters per year. So h prime of 6, well, I mean, I have to estimate it because I have to use 2 points. And then what I'm going to do is just use the 2 points that are closest to it. So if I find the slope between these, that'll give me a decent estimate for the slope at 6. So you'll see that's what I did here. Use 5 and 7 since they're the closest. Derivative is the slope, and then it's just y2 minus y1 over x2 minus x1. So I get 5 halves, that is meters per year, and that's the growth of the tree. That's the change in the height of the tree, or the growth. Part B, explain why there must be at least one spot where the derivative equals 2. Well, if you remember the mean value theorem, the mean value theorem was when we drew it, like I would draw a line, like 2 dots like this, and I'd have you guys fill it in. And the idea is there's no way you can fill it in without making at least one spot where the slope matches the slope between the endpoints. So if the derivative is going to be 2, that means there must be a spot where the slope between 2 points is 2. And you just got to kind of look and find it. You know, I started off with 2 and 10 because that's what they gave me. So I assumed if I did like 15 minus 1.5 over 10 minus 2, that would give me 2, but it didn't. So at first I was like, wait a minute, maybe this doesn't work. But then if you just kind of keep looking through other possibilities, so for example, 15 minus 11 is 4 over 3. Well, that's not 2. But if I look here at these two, y2 minus y1 over x2 minus x1, I'd get 4 over 2. And so if the slope between those 2 points is 2, we are guaranteed to get a derivative of 2 somewhere in between them. And since that's also in between 2 and 10, that's what we're going for. So here's what I wrote out. So since it's differentiable, we can use the mean value theorem. I do think they would want you to see right that there, the mean value theorem, or MVT, which says that there must be a value where the derivative equals the slope between the endpoints. That I'm just showing my work, like I just talked about. Part C is trap rule, but they throw this little twist in here, which would be really easy to miss. So it's the average height. If you remember average height, you take the integral and you divide by the length. So the average value or the average height is the integral divided by the length. And the integral in this case isn't really an integral. It's like the trap rule used in its place to estimate the integral and then divide by the length. So I could see a lot of people getting to there thinking you did some good work, and you did. You found the left sum, you found the right sum, you average them together. That's trap. But the average value over that 8 units, you got to divide by 8. And that comes out to your answer, or any version of that. You know, if you had So if I doubled that, well, that would be 263 over 32. Is another way you could do it. Part D took a whole other sheet of paper. Part D was kind of rough. I mean, it's not bad. None of it's bad. It's just been so long since you guys have done it. It's just hard. All right. So they give us the height of the tree is this g of x function right here, where x is the diameter of the base of the tree. And the tree is 50 meters tall. So right there, they're giving me g. So they're telling me g is 50. So what I did with that, I didn't do it till the end, but I'm going to explain it first. What I did with that was plug in 50 here, multiply both sides by 1 plus x, divide by 50 to get this, and I found out x equals 1. So what I found was the diameter of the tree. So this is your diameter. And then they want to know the change of the height. Well, the change of the growth or the change in the height, that's a derivative. So we have to use quotient rule in this case. So this is my quotient rule. This is me simplifying my quotient rule. And then we multiply by dx dt because it's one of those related rates deals where everything's changing with time. So remember, like, you take the derivative of an L, you multiply by dl dt, for example. That's what this is too, and I know that because there's all these different variables changing with respect to time. So that's a key phrase that you see there. So then, putting this all together, and I apologize, I feel like I'm all over the place, but I got my diameter here that I'm plugging in for x. They told me dx dt is 0.03, and then I just multiply across and get 3/4. All right, number 5. Again, let me find my work here. If you watch this, I'd appreciate it. Just give me a shout. I don't care if you say, hey, your video sucked, I don't understand it, or thanks for the video, or whatever. But just email me or something and give me a quick note. Let me know that you saw it. I'd really appreciate it. Okay. Part A here, number 5. So they give me this equation. Number 5 is tough. And you'll notice this as you go. I don't know if it'll be true this year, but typically it gets a little tougher as you go. So number 5 and number 6 on the free response are usually the toughest ones. And I think that's the case here also. So the average rate of change is just the average slope. So that average slope is not calculus. Average slope is just the slope between the endpoints. So you're just doing y2 minus y1 over x2 minus x1. So you're plugging in pi to the original equation minus plugging in 0 to the original equation to find the y2 and the y1. And these are your x2 minus x1. So if I plug in, here's what I get, and then just working through and simplifying, I get to here. Part B says, what's the slope of the tangent line? Okay, well now we're talking derivative. So remember product rule. I got to do the second thing times the derivative of the first thing plus the first thing times the derivative of the second thing. And this is what they're going to do. They have to check all of your knowledge in a lot fewer questions than they used to. So they're going to be all kinds of concepts within one problem. So be on the lookout for multiple concepts going on at once. Product rule, quotient rule, integrals, derivatives. So just something to be aware of. If you think you're not using enough concepts, that's probably a good instinct, and just double check that you're not missing something. So then I plug in, they want to know the slope of the tangent line at 3 pi over 2. So I plug in 3 pi over 2 here. And then if you work it out, I don't really want to talk through working it out because people will get bored and stop watching, but you end up with this e to the 3 pi over 2. Part C, and you'll notice this is the second time that this has been on here. So the absolute minimum value, and it could be absolute maximum too, but they asked absolute minimum already on this free response. So you can tell they think that's a pretty important concept. So again, if we're looking absolute min or absolute max, we check endpoints and critical points. Well, here they told me I'm going between 0 and 2 pi. So those are my endpoints. Well, how did I get these? These are y values. To get y values, you plug into the original equation. So this is me plugging 0 into the original equation. I'll just write down the original equation here for you. So if I plug in 0, you'll see I get like e to the 0, which is 1, times cosine of 0, which is 1. So 1 times 1 is 1. If I plug in 2 pi, I get e to the 2 pi times 1, so I get e to the 2 pi. Well, then you need critical points also. That's a little tougher in this one. Critical points are when the derivative equals 0. So I have my derivative from up here. Like I already wrote it up here, so it's this guy. We did the product rule, and I got to set it equal to 0. So I added the sine of x to both sides, and then I canceled out the e to the x, and I get cosine equals sine. So they give me the boundaries of 0 to 2 pi. So 0 to 2 pi is just once around the circle. 0, pi, 2 pi. So where in there are the cosine and the sine the exact same values? Well, right there at 45, which is pi over 4. And right there at 225, which is 5 pi over 4. Because here they're both positive, here they're both negative. So then those become my critical points. And then these two things also need to be plugged into my original equation to get these two y values. And that's a little tougher to do, but still not bad. All right, then part D, this is L'Hopital's rule, which we briefly hit on. So they're kind of setting it up for you. They're telling me, well, they said find this or state that it doesn't exist, but I can't find this right now because I will get 0 over 0. If I plug in right now, I'm going to get 0 over 0. So that tells me I'm just kind of like the state that doesn't exist. So find the this whole thing just sets up to, like, right away I thought L'Hopital's, because that's the general setup here is L'Hopital's. Is if you have the limit as x approaches something of f over g, which is what they're giving you here, as long as you get 0 over 0, you can say, hey, I'm going to use L'Hopital's, LH, and then you got to write out the limit stuff again, but you can then use the derivatives to plug into instead of the original. So since this is g prime of x, now I can read this graph, because this graph was g prime. If I had, before I was asking for g, I don't know g. But g prime of pi over 2, that's 2. I can read that off. And then I need f prime of pi over 2 also. Well, f prime is that derivative that I had. So this is my f prime. So they really hammered on this one. And your job is to plug pi over 2 into that. And if you work through that correctly, you will get this negative e to the pi over 2. All right. One more, and this is a topic we didn't get to, so it's going to be rough to practice all of these things without being in class. I apologize for that. I feel so bad that you guys can't get instruction on this, but we'll do the best we can. I think the con videos are really good. I think the AP videos are really good. It's just a matter of, it's hard to motivate yourself to do them. I know it. Just do the best you can. So a slope field, what this represents is all of the possible slopes at any point on a grid. So my line here actually tries to represent an original function. So it's almost like we can see like information about the derivative. So for example, the original equation has a positive, relatively steep slope here. So this might be like x equals 3. Well, at x equals 3, the slope is positive and pretty steep. I'm sorry, at x equals 3 and y equals 0. At this point here, let's say 0, 1, the slope there is 0. I get a horizontal line. And if you plug 0, 1 in here, 0 for x and 1 for y, you would get a slope of 0. So you'll see, like, if I plug in 0 for x, none of the rest of this stuff matters. So if x is 0, your slope is always going to be 0. And that's what you see right here. When x is 0, you get all these little horizontal ticks. So no matter where I am, y value wise, if I'm on the y-axis, which is when x equals 0, then my slope is 0. So that's a brief overview. So if I said, what's the slope at 3, 6? You would plug 3 in for x and 6 in for y, and you could figure it out. So they're saying sketch the solution curve. So through 1, 0, you want to just try to you know, I got a slope here that's this, a slope here that's this. My line goes in between them, so my slope should probably be kind of in between them. It's almost like these are like the airplane light guider things, and you're trying to stay within the lines, but also follow the pattern. So you get something like that. And then at 0, 2, everything's horizontal. Everything's just a horizontal tick there, so you can just go straight across. Part B, f of x be the particular solution to the differential equation with the initial equation. So they're giving me a point here. X comma y is 1 comma 0. Write an equation for the tangent line. Okay, tangent line we've done a million times. So blank times x minus blank plus blank. I put my x value in there, I put my y value in there, and then what goes in this slot is the slope. Well, to find the slope, we want to plug into the derivative. So the derivative is this 1/3 x times y minus 2 squared. So I want to plug in 1 for x, y minus 2 squared, so 0 for y. If you work through that, you get 4/3, so that 4/3 is what goes in this slot. And then what they're saying is use your equation to approximate f of 0.7. So you plug 0.7 in for x into your new tangent line equation. And if you work through that, you get negative 0.4. So that was not bad. Even though it's new material, it's at least similar to what you've seen before. And then part C is where it just gets, I'm going to talk through it. If you haven't watched the videos on this, you're going to be completely lost. And I would strongly recommend you do that. What they're saying is basically find the original equation. So they're saying, here's your derivative. We also know f of 1 equals 0, so we have a point at 1 comma 0. Can you work through this, all the way backwards and find the original equation? So the first thing we have to do is realize that we need to integrate because we're at the derivative level and they're asking me to find the original. So they're asking me to find y. So I got to go up a level. So I got to integrate. Well, I've got two variables, and that's a problem. So I'm going to separate those. This is called separation of variables. So I'm going to put all the y's on the left-hand side, and I'm going to put all the x's on the right-hand side. And then I can basically do whatever I want to both sides of an equation. So once I get y's over here, x's over here, I'm just going to integrate both sides. I can do that. So I divided both sides by this y minus 2 squared, ended up down here. And I multiplied both sides by the dx. So basically I flip-flopped these two things. And then I get this. Still not really in a setup I can integrate. So then I brought the y minus 2 up. And now that looks a little more like kind of what I'm used to seeing as far as integration. So on the left-hand side, again, this is not really u substitution because if I made u equal to y minus 2, du is just 1. So I don't really need to worry about the du setup. I can just add 1 to the power, multiply by the reciprocal of the power, and I end up here. And then the integral of 1/3, so I add 1 to the power, multiply by the reciprocal, and I get here. So there's technically a plus c on both sides. But if you imagine what would happen, I'd bring this c over to join with this c, and then a constant plus a constant is just another constant. So you don't really need to write this one. This kind of represents both of them together. And that's just kind of the standard. You put it on the right-hand side. Well, then, this is my original equation. It's not pretty. It's not in the y equals form yet, but that's my original equation. So I can use that to find out what c is. So this is our information that we had there, 1 and 0. So what I did was put 0 in for y and 1 in for x. And then I can find out what c is. So if I work through that, I get c is 1/3. So now I can rewrite this equation. So that's what I'm doing down here. I'm rewriting this equation, but it's a better version of it because now I know what c is. So I had this before, I worked through here to find c, and I get this. And this is my original equation. The problem with it is they want y by itself. So they said, find the particular solution, y equals. So there's just some messy algebra that has to happen here. So the first thing I did was multiply both sides by 6. And I did that because it would get rid of the fractions. Sorry, by -6. So I multiplied everything in here by -6. So that gives me a 6 there. That would be negative, and that would be negative. So then what I did was just rewrite. So this is wrong. All right. Okay. Then what I did was just move this down to the bottom. So it's a negative exponent, so it goes to the bottom. And then I can do that flip-flop trick again. So this goes 6 over this, and then the y minus 2 goes up here. And then I just add 2 to both sides, and then you get y by itself. So there it is. Please let me know if I can help. Reach out, email, Schoology, Hangouts. We can do a Zoom call. We can do whatever you would like to do, whether it's help on this or anything. Hope you guys are doing well. And stay safe, and we'll talk to you soon.